Okay, chapter 5. We are going to continue focusing on triangles specifically throughout this chapter. It gets just a little bit more difficult because we're going to start looking at special segments within triangles and some other relationships. Specifically in section 1, we're going to take a look at two special segments, one being the perpendicular bisectors in a triangle, and we will look at angle bisectors in a triangle. So we're first going to start with perpendicular bisectors. And what are they? Well, a perpendicular bisects and is perpendicular to a segment. In other words, if you look at this picture over here, bisect meaning it's going to split my segment into two congruent segments. So JR here, this segment is going to be equal to this segment. So it's splitting that segment straight in half, and if we're going to say it's perpendicular, it therefore has to cross at a right angle, which you can see there on that picture. Okay? So that's the idea of it. Now, when we deal with perpendicular bisectors, we get a couple theorems out of this. And really the main important parts that I need you to understand out of this, either looking at either box, is if I form a perpendicular bisector, then AD should be congruent to DB, looking at this picture, along with AC being congruent to CB, as long as point C lies on that perpendicular bisector. That's the main important part. Okay, so a couple examples. This is what that looks like. It wants you to determine the value of AB. So you first need to determine, is CA a perpendicular bisector? In this case, it should be. It's crossing at a right angle, and it's splitting BD into two congruent segments. So if AD is 4.1, then AB should be 4.1. Alright, so that's letter A. Letter B. Again, you need to determine whether XY is a perpendicular bisector. I know it's crossing at a right angle, and it also has to be a perpendicular bisector because this is congruent to this one. Therefore, if I want to find WY, which is this one right down here, it should be the same as this value here. In other words, this value is 3. And finally, last one, letter C. Again, determine whether RS is a perpendicular bisector. It is. We have a right angle, and we have two congruent segments. So therefore, this one should be congruent to that one. And if they're congruent, to form our equation, we should get 2x plus 3 equal to 4x minus 7. To solve this, let's subtract 2x to get 2x, and then if we add our 7 over, we should get 10. And then if we divide by 2 on both sides, we should get x equaling 5. We don't really want x equaling 5. We still want to find the value of RT. So I'm going to find RT from up above. It's right here. And I'm going to plug 5 into it. So 4 times 5 minus 7. 4 times 5 is going to get us 20 minus 7, which will therefore get us a value of 13 as your final answer.